Hi. So in the lecture today, in the video today, we will say a few things about data structures in R, some other data structures. We have already seen in previous videos vectors, and now we'll see matrices and data frames. So we can see that vectors are one-dimensional constructions that save, or we can store there values of similar type. For example, we can store numbers, which means that in all positions of the vectors we should have numbers. We cannot mix numbers and characters, for example. Or we can store characters, and in R by characters we mean actually characters or strings like A or AB and so on. Or we can store logical values like true or false. Now matrices follow exactly the same logic like vectors. In fact, a matrix is a vector but represented in 2 dimensions instead of 1. So a matrix M is a 2-dimensional construction that has n rows and m columns, and for example it has values of exactly the same type like 1, 1.2, 3.2 and so on. M values here, m values here, so this should be m, and n values in this dimension. Okay, how we get a specific element in this matrix M? It's by using the square bracket, and we use a comma. Whatever is below the comma will be referred to the row. So for example, if we want an element from the second row, this 2.3 for example, it will be the second row. Remember, R starts counting from 1 and not from 0, so this is row number 1, this is row number 2, and then this element again is the second on the second column, so it will be M22. And with this way we can get the element and view it. For example, if I will write here print, it will print out 2.3, but we can also set the element. So M23 equals 5. It means that in this matrix M, all other elements will be the same like they were before, but now this 2.3 that was here, it will be replaced by 5. Everything else will be the same. Sorry, here I should write 2.2. My mistake. So second row, second column. Okay, so if I want to get one specific column, so for example the third column, get a column, then it means that I need to take all rows, so I don't put anything here. I don't even need to put a white space. It can be just comma immediately after the square bracket, and then I need the third column, so it will be 0.3, and this, it will be a vector. So if for example here I have the values, let me make some space, 3, 4, 4, 5, this will be a vector 3, 4, 4, 5. And similarly, if I want to get a specific row, it will be like that. If I want to get the second row, it will be 2 comma. So all columns for the specific row. And again, this will be a vector. And here it could be get a row. Okay, if I want to get a specific subset of the matrix, so let's suppose again that this is a matrix, and now I want to get this submatrix which consists of columns 2 and 3 and all rows here, then it will be m, 2 to 3, or m, 2 to 3. Now with this way, of course I get consecutive columns, but using this way I can get any arbitrary columns. Of course, I can expand this a little bit, and if I want to get all the even numbered columns, I can do something like sec from 2 to and call m by equals to 2. So this will start from 2, which is the first even numbered column. It will end to n column to the number of columns of m if it can get there, so if this is an even number, and the step will be 2. For example, if this is 11, like this is an odd number, then it will start from 2 and it will be the numbers 2, 4, 6, 8, 10, and it will stop here because the next number is 12, which is greater than 11. It will not get to 12. So of course you can use here all the different ways that we can get a vector. Another possible way here is from 1 to 5 and all this multiplied by 2, because this is a vector 1, 2, 3, 4, 5, and multiplied by 2 it will be the vector 2, 4, 6, 8, 10. So this is the same like 2, 4, 6, 8, 10. Okay, now this is a way to get sub matrices if we are interested on specific columns. The same is true for specific rows. So for example, I can get this part easily just by using the first part before the comma, so this part here, and if we combine this we can get specific parts of the matrix like this one. So let's suppose that this is between rows 4 and 6, and this is between rows columns 3 and 5. Then I can say, and I want these values here, I can say that I want from m the 4 to 6 rows and 3 to 5 columns. This will be exactly the same like 4, 5, 6 and and 3, 4, 5, or sec from 4 to 6 by step 1 and secs from 3 to 5 by step 1. Another question that we might have at some point is to get 10 random rows with replacement from the matrix. So this could be again a new matrix. The second 10 random rows, columns will be empty here. So sample from let's see how to do that. So sample from 1 to n row of m. Let's make some space. Ten values with replace equals true. So this all means 10 random integers will be sampled from 1 to the number of rows of m, which, let's say, for example, 10. For example, 10. And if I want to sample 10 random numbers from here with replacement, then I might get something like 1, 2, 2, 5, 8, 3, 2, 1, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are 10 random numbers between 1 and 10 with replacement. So the result of this will be a new matrix. I need to close this parenthesis here. Now this will be a new matrix